All right, so last lesson in this, or last video for this lesson. I keep calling these videos lessons, and they're really kind of all part of one big general lesson. But so the last thing we're going to look at with solving quadratic equations through the use of graphing is situations where it doesn't have any real roots. Now, there's two really, all these words kind of need to be unpacked. So no obviously means there's no roots, right? Look at no roots. Well, if there's no roots, think about what that means visually. When we had two roots, it crossed our x-axis in 2 points. When there was one root, it kind of rested on the x-axis where the vertex was on the x-axis. So if there's no real roots, if there's no roots, that means it never touches the x-axis. It doesn't go through it, it doesn't touch it. It could be really, really close to it, but it doesn't touch it. And then the word real in this case, they have to make that distinction because there is a whole subset of numbers you're going to learn about later on called imaginary numbers and complex numbers. And it's pretty wild, and it's really interesting stuff, but we're not at the point yet where you need to know about that. But they are an actual thing. But so when we talk about real numbers, we're talking about integers, fractions, rational, irrational numbers, pi, things like that. Those are all part of the whole real number subset. So we're saying that there's no roots to these that fall with those. So you set these things equal to 0 and you get nothing like that. So we've kind of covered what the roots are, right? Several times over, beat it to death. So solve the equation by graphing. All right, I don't need to write this, leave this out because you've seen this a bazillion times now. So let's take our equation editor out, and we're going to solve this by, we're going to put a y in there because we need a y. You need two variables if you're going to plot this on a Cartesian plane. And then we're going to get all this stuff on one side. So we're going to leave this stuff where it is, and we're going to go negative x squared, and then minus 3x, and then we're going to move this 5 over to the same side that this is on. And because it's positive here, when I move it over to the other side, it becomes negative. And it becomes negative because you're subtracting 5 from both sides to keep the equation balanced. So I have this mess right here, this negative x squared minus 3x minus 5. You go over to decimals and see how much y equals negative x squared minus 3x minus 5. All right, and so I've got this equation right here. Let me make sure I put the right thing in. I'm pretty sure I did. Turned out the way we wanted it to anyway. So if you take a look at this, we raise this up, right? It looks like its vertex is somewhere over here. That would be, let's see, negative 3, so 1.5, whatever, somewhere around there. But it never touches the x-axis at any point. So if it doesn't touch the x-axis, that means there's no point where if I make this equation equal to 0, where I can find a solution that will work for it. Okay, so this has no real number solution to it, all right, or no solution for our purposes right now. And like we said, later on you'll discover that it does have a solution, but it's rooted in a complex number. Okay, and so let's take a look at another one. All right, so let's take a look at this one right here. You got negative 2x squared minus 8 equals 6x. So let's rewrite this one as y is equal to, well, we have negative 2x squared, then we got our minus 8, and then we'll move our 6x over to the other side. And because it's positive here, when it gets moved over to the other side, it will take on a negative sign. And then I am just going to rewrite this one more time for you guys so that we are completely in agreement that it is in standard form. I can't sit and make you do things like this if I'm not willing to adhere to the same conventions. All right, so you got negative 2x squared minus 6x minus 8. All right. So, and if you kind of look at it, it's it's kind of a situation where you're like, oh, I don't know. I don't know if that has a real root, right? So let's check it out. Let's see what we can do. So negative 2x squared minus 6x minus 8. So y equals negative 2x squared. Oh, I didn't put in the square, did I? Minus 6x minus 8. And we have something that's almost identical to the other one, right? So again, it does not cross the x-axis. It crosses the y-axis. And most of these at some point they'll all cross the y-axis at some point, right? But only in one spot. And that's not the solution to the equation when you set y equal to 0, obviously. So I wonder what would happen if I took this and I made all of these. See, if I make this positive, you see all of a sudden now it has two roots, right? Well, what happens if I make this positive? Well, if I make it positive, it just kind of moves it over. What if I make this positive? So it's opening upwards. Check that out. So again, we have another situation where it has no solutions, no real roots, because it never touches this axis down here. So these are parabolas are really interesting things. They model, the way things travel and are affected by gravity, and a lot of other interesting things. So yeah, I hope you're finding this at least somewhat interesting. So this is our no roots, and you should be all good now to get cracking on the homework.